Welcome to the Lippis Report.
Hello everyone, and welcome to another edition of the Lippis Report podcast. I'm Nick Lippis, your host for today's discussion with Steven Shalita, Vice President of Marketing at NetScout, as we discuss NetScout's focus on providing performance management that spans the application to network stack. Well, let me give you a brief intro to the topic before I bring Steve into the general discussion. And as you can tell, we're recording live from CiscoLive. Well, at the Open Networking User Group in spring, which was hosted by Citigroup in New York City, IT business leaders stressed the fact that networking is opaque, that it's mostly invisible versus server and storage management tools available. To understand and control application performance, what is needed is a way to automate the creation of an application dependency map that spans applications, compute, storage, and networking across data center, campus, and WAN to enable cross-functional application troubleshooting and performance optimization. This is the Holy Grail of IT, as it enables business resiliency and lowers OpEx. As the requirements for IT agility increase, administrators are constantly pressed to increase the speed with which they can deploy, manage, and troubleshoot applications across compute, storage, and networking domains. For instance, the building of an application dependency map for applications that span across firewalls, IPSs, load balancers, switches, virtual machines, bare metal servers, routers, WAN link storage, VLANs, and all these other components is required to deliver and service applications. With no map of these dependencies and limited visibility, how are IT professionals conduct change management, troubleshooting, monitoring, performance optimization, and all the other activities they need to conduct? How is application behavior assured, realized when various applications' responsibility dependencies are shared across administrative domains of compute, network, and storage? To create an application dependency map today, NetOps has only a manual sniffer in its tool chest. What you really needed is an automated approach to build an application dependency map that can be shared across multiple administrative domains. NetScout is in an optimal space to deliver this value. We'll find out how they are approaching performance management in this Lippis Report as I talk with Steven Shalita of NetScout. So without any further ado, let me say hi to Steve.
How you doing, Nick?
I'm excellent, Steve. Great to see you. Thank you for being here as well.
Thank you.
So performance management layer, right? Kind of new concept for the industry. So really, what is it about?
Well, and I think even in the sense of the new concept, there's a lot of confusion in the sense of what represents performance management today. We've kind of seen some evolution, just like we've seen in the networking industry, the IT industry as a whole, where things have moved from really looking at the performance of networks to really being more concerned about the performance of services or what's being delivered to the user, right? Today's network infrastructure's changed a lot from the traditional, I've got a server, I've got a switch or a router, and I just make some connections in between. There's massive layers of complexity in there. So today's performance management is really about looking at availability, of the quality of service and the overall performance of the service, and ultimately, what's the user's experience with these applications or services. Yeah,
very good. So what's really key about this performance management layer is an application dependency map, right? So like what is dependent upon that application? So the load balancers, firewalls, switching, routing, all that stuff that goes into like an application. So NetScout is now defining this application dependency map, which is an automated way to kind of build that. So can you talk to that?
Yeah, absolutely. I think you really hit a key point, and that is in today's, we call it services, right? What a user on the network is consuming is a service. So before I answer that question, let's define what that means. A service ultimately is the culmination of lots of different elements running behind it. The application, well, there's multiple tiers to the application. There's the database side, there's the web tier, there's all these different pieces, and as you said, the load balancers. So today's service is made up of multiple applications, multiple protocols, and a lot of networking layers. And the key in really understanding performance in today's environment is the dependencies on each of these moving parts, right? Ultimately, the whole is greater than the individual pieces. So how do you understand how an application is moving from its server across different application tiers, what load balancer it's hitting, and even beyond load balancer, things like DNS, DHCP, single sign-on, cloud-based services, all of these represent dependencies within the relationship model of a service. So being able to understand how the interaction is happening and the performance at each one of those interactions is critical. But how do you figure out what's dependent upon what? You're going to spend hours mapping it out and creating a deterministic path to these things? No, you're going to create load balancing and resiliency to keep the network up and running. So what NetScout's done with our Ingenious One and ASI technology is enabled the automated discovery of dependencies for applications or services to make it simpler to model and simpler to monitor, simpler to understand how these interactions are actually performing, and that's key. So the old approach would be you'd have to map it out and say, I'm going to look at these pieces and I'm going to depend upon this application to interact with this component every single time. In an automated way, we can see the flows that are happening in the network in real time and build a dependency model and then be able to look at performance across each one of those interactions.
That's key, and I think the key word that you mentioned in this is automated.
Automated.
So it's an automated way, because the way that most network architects and the NetOps folks do this today, they use sniffers. So it's a very manual process to try to understand what the dependencies are for applications. So that's great. So it's kind of an automated way to kind of discover all those dependencies. And I think what you were also describing is that when you have this map, then you have this model that you can share with other silos and other groups to like aid in the troubleshooting and performance monitoring and monitoring of an application. So can you talk a little bit about that? Like, once you do have this dependency map, how does that get shared amongst maybe storage and the application group, the virtualization group, the networking group, and so forth?
So typically in a monitoring scenario, most organizations start with the dashboard. And the dashboard allows them to essentially get a top-down view of a particular service. Every organization is different, but for the most part, they're going to look at the consumed service at a dashboard, see how it's performing. They're then going to leverage the dependency mapping to understand where the performance issues may lie within that communications chain. So it's very important to kind of delineate here to really be effective in service delivery monitoring at an enterprise level. It's really about that application or service, the communities of users, not individual users at this point, right? What you want to look at is broader context of connectivity and service levels, and then you potentially may want to drill down an individual user session. So being able to automatically discover these interactions is really important, right? If you're using an agent-based approach, you have to know where the servers are to place those agents to be able to do this. Right. Using a passive monitoring appliance allows you to look at the network itself, actually see the traffic that's flowing, and map all of those dependencies. Typically, network operations, the network operations center, application operations teams are going to leverage this as their primary source. And it depends upon in the organization who's responsible for top-level service delivery. In some cases, it's the network team. In other cases, it's the application team. But once you actually get into looking at this top-down service view, I see that there's a problem. I'm able to isolate where in the enterprise architecture that problem is coming from. Say it's single sign-on or DHCP or a load balancer issue. And then I can allow the different teams to actually go in and solve that problem. So what you end up with is a single tool that everyone can share. So if I start at the dashboard, it's telling me the holistic view of that service. As I get into dependency mapping, it starts to tell me performance characteristics at each one of those tiers, at each one of those dependency points, latency, retries, things like that, that would then allow a particular team to go in and triage and then troubleshoot the problems. They may need to use a point tool to actually go into the application layer or into the load balancer, but at this level, it allows them to quickly identify where to focus their efforts and which team to be working on.
That's great. So a shared dashboard. So all the different silos can now have access to that dashboard. They can see if there's a change in state somewhere in the network that's impacting some user experience on the application. These teams can now collaborate, work together, kind of figure out what happened, and basically troubleshoot, fix the problem.
Right, and a couple of key things there. One is it used to be green, yellow, red kind of indication. We've tried to take that away and make it even simpler and a little less harsh in the sense of how you grade that, so you can really tune the performance levels, right? Second is to also provide some early warning. Most issues that happen in a networked environment manifest over time. It's pretty unlikely that something's going to flip a switch and fail other than a complete outage, power failure, cable cut, right? Most problems start small, you start seeing subtle signs, but most people miss that from a pure performance perspective. So what we're looking at is, how is that performance trending? How are things from a baseline perspective, and actually giving early warning of issues as they're emerging before a large number of users can be affected, and then go in and do the triaging. And triage is really important, being able to figure out what the impact is to the business, what element is causing that problem, then you can get into troubleshooting. Most organizations take what I would call the rule-out approach. Same thing as a doctor or a car mechanic, right? We'll go look at this, is that the problem? We'll look at that area, is that the problem? Most cases, the network guys, they end up having to defend the honor of the network and prove it's not the network problem.
That's true.
Right? Taking from this perspective, you're actually able to very quickly pinpoint, is it network, is it this layer in the architecture, is an application server issue, and get much more clearer view to go in and focus the effort on the right place.
Yeah, that's great, really. So it's the entire application stack down into the network. You can actually see what's going on. And networks have been opaque, to the application groups. You can't see them. So look, this is one of the first tools that really does an automated way to kind of create the dependency map that can be shared across multiple groups.
Right.
That's great, Steve. So then, how do you implement this? So like you're an IT architect, what are the piece parts from NetScout that you need to actually put into your network in order to kind of like now build a dependency map and actually start managing your infrastructure more intelligently?
It's something we've added to our core technology. We introduced Ingenious One, which is a unified application network performance management platform last June, right? And that really built on the technology that we've been delivering for a number of years with our Ingenious solution. The fundamental architecture, the building block, is monitoring appliances, and that can be physical or virtual. So it's a probe-like device that physically sits on the network, right? You can facilitate connectivity in the network directly. You can use network monitoring switches that we offer that are fully integrated to provide that connection. The appliance is sitting there doing deep packet inspection, looking at all traffic all the time. And it's important to mention, you talked about networks being opaque. Really what's happened is the network has become the key vantage point. There's nothing that provides you visibility into all these moving parts more than the network packets, because it's carrying every piece of that interaction.
Right.
So that appliance is sitting there looking at it in real time, understanding all of these sessions, traffic flow, applications, application performance. The probe itself, the appliance, is doing all of the analysis in real time. Our adaptive session intelligence is doing all the application-specific metrics, network-specific metrics, and then we roll that up to our analytics console, the Ingenious One platform, that actually allows you to go in and actually look at that data and turn it into information, right? So you've got massive big data happening across a distributed network. Let's take some of the largest networks with literally hundreds of physical locations, thousands of applications, and 10,000 users within that environment. Could be deployed within a data center with a handful of appliances, or a network monitoring switch and an appliance, and all those metrics then get pulled up. The goal is to get end to end. We've also virtualized that appliance so we can integrate that into a Cisco integrated services router. So you can put out at the branch office a way to get visibility without the expense of a probe or an appliance. We have a virtualized version that sits inside of a virtual server, so we can see interactions across the hypervisor. And as network function virtualization takes broader hold in the market, especially on the enterprise side, you'll start to see that probe getting more and more virtualized, so it can be deployed in more places in the network. We call it virtualized adaptive session intelligence, and that's the patented technology, the secret sauce that really allows us to do all of this and scale at really mass proportions.
Great, excellent, Steve. Well, I think that's all the time that we have for this particular session. Great discussion around performance management layer and how NetScout can basically provide first, really, some views into the network and some analytics around the network on how you can actually manage application performance. So, Steve, thank you very much.
Thanks very much, Nick. Great to be here.
And thank you, everyone, for watching.
That concludes this edition of the Lippis Report. Thank you for joining us. Look for us every Tuesday and Thursday. To get your free subscription to the Lippis Report newsletter, go to www.lippisreport.com. To sponsor the Lippis Report podcast, send email to sales@lippis.com. We've got to go, and so do you. See you next time.